This is how to use the Logger Pro software with the oxygen electrode and measuring crayfish metabolic rate. So you open up the file. I'll show you the icon will look something like this. And then that should open up this file. It has a previous run on there. This is dissolved oxygen on the y-axis and time on the x-axis. So we're going to start collecting. It says, what do you want to do? Well, we want to erase because this is somebody else's data. So erase and continue. And you can see over here on the left, we're starting to get a little graph line showing up on the chart showing the dissolved oxygen. Also in the table over here on the left, it gives a readout of dissolved oxygen, about 6.6, and also the temperature because we have a temperature probe in there. Okay, so the idea here is that we have the crayfish in the chamber. It's not sealed though. We have a bubbler in there so that actually the bubbler and the crayfish are competing. The crayfish is using oxygen, the bubbler is producing, but the bubbler is producing a lot more. So what we should see is a steady oxygen level at about the level where you'd expect the water to be saturated with oxygen. We want to make sure that this line right here is relatively stable. Shouldn't be going up or down, it should be stable because that's going to be our baseline. Once we close the system, take the bubbler out and close it, then the oxygen level should start dropping downhill like that. Which is going to be an indication of our metabolic rate. So we should go at least 5 minutes just to make sure that it's stable. While we're waiting, there's a really cool thing with a lot of cool things with this program. But one of them is you can put little text markers. So if you go up to Insert Text Annotation, get this, move it out of the way. You can put something in there like system closed here, or whatever you want to put there. And then this pointer can be moved around anywhere you want. So if we wanted to start right here, we'd put the pointer there. But we don't know where it's going to start yet. We'll just get it out of the way. And it looks like the baseline is relatively stable, maybe a slight increase that would indicate more oxygen is getting in there, but it's pretty good. So I'm going to seal the chamber now, take the bubbler out. Okay, the bubbler is out. So the system is closed, so I'm going to put my pointer at that point. And we're going to see what happens. If the crayfish is respiring, the slope should go down. So that should probably take a good 10 minutes to get a good rate on that. We're trying this with a single crayfish. Of course, we would get a much more rapid rate if we had two, but we're going to try one today. Okay, as you can see on the graph, we've gone from about 6 minutes to about 13 minutes, and there's a nice downhill slope there, just using one crayfish. So I think we're getting near the point where taking the slope is meaningful. We have enough duration and enough confidence that that is a nice downhill slope. So I'm going to let it go about 1 minute, and then we'll stop the graph and see how you get a slope. The slope, of course, is going to be proportional to the rate. So again, the y-axis is dissolved oxygen. It's in milligrams of oxygen per liter. And the x-axis is in minutes. There's a limit to how long we could run this because the as the animal is using up oxygen, it's going to become more stressed, but it's still above 6 milligrams per liter, so that's a good amount. If it got down to 4, I would start worrying about the crayfish. That choppiness could be due to a lot of things. It could be due to the crayfish moving around. It could be electronic noise, differences in mixing. We don't really know, but that's why we need to take a nice long time sample. Well, I don't know what that last spike is. Let's see if it levels off. Maybe the crayfish got in front of the electrode. That's probably what happened. Yeah. All right, I'm just going to stop it there. Stop. And now we need to take a slope. So you go up to the menu item, called Analyze, and you do Examine. And then the point we're going to, the region we're going to examine is from where we started to the end. You can see it highlights it. But right there. And then you go up to the same menu, and we're going to assume that's linear, so we do linear fit. And it gives you an equation. You can move the box around. So here's our equation, y equals mt plus b. But the only thing we're interested in is m, because that's the slope. So the slope is minus, 2 significant figures is fine for this, minus 0.06. So you would record that on your data sheet, and then that gets converted to a more appropriate unit, to, based on the grams of animal and other things that you will find in your lab manual. So that's what you record. All you need to record is m, and then that will go on your data sheet and then probably recorded on your instructor's computer for class data. That's about it. You don't need to save this run. Just save the data. Oh yes, one other thing. At this point, we want to keep the crayfish happy, so we're going to open up the system and put the bubbler back in. Probably should have done that first. Give him lots of oxygen.